So we're about to start with the first panel. I thank Michael for asking me to serve as the chair. It's very characteristic of Michael's organization that we start punctually on time, so very tidy, but informal. So I won't be presenting at length the speakers, only by title. Our first speaker is Professor Varda Shalev. She is the CEO of Maccabi-Tech, and she will offer us state-of-the-art first presentation.
Okay, so first, thank you, Michael, and Monash University for bringing this fascinating topic and innovative topic to the table. And I'll tell you a little bit about what we are doing in Maccabi and in Tel Aviv University. And I'll show you a few of our debates within Maccabi, and Shelia Hanochi, which is the head of the legal, is here. And I ask her questions on a daily basis because we struggle with many issues. So let's start. We work with everybody, with pharma companies, with IBM, and with the academy, of course. And Maccabi has about 2 million members, which is about a quarter of the population of Israel. And we are quite a typical share of Israel. If you look at sex, age, etc., our monthly income is higher than the average. But if we want to see whether big is big, you said big, so we can look at the HMORN, the HMO Research Network of the US, where Maccabi is the only partner out of the US. And you can see that even in this network, we are third in size. So we are big, okay? 2 million is big.
Does that include the dead people?
No, 2 million is the, but if we look at that, which is very important for algorithmics, so we are even bigger because the retention rate of our patient is the higher in the network. And we have data, digital data for a long time, so it's even bigger, okay? And the retention rate is very important because if you want to follow a patient from cradle to grave, we have the opportunity to do it. And we have a unique ID in Israel, and I know that it looks trivial, but it's not. I just came back from a conference where Ireland presented a very important issue that they have a unique ID now for patient for medical purposes. So we have it for many, many years, since Israel was founded. We have EMR, electronic medical record, for many years. Maccabi was the first one to implement electronic patient record. By the way, I did not present myself. I'm a family physician. I'm a practicing family physician. I've specialized in medical informatics and founded this department in Maccabi. And now I'm the head of the Research Institute of Maccabi and Cannes Data Science Research Center. So we collect data. For many years, whatever we see, we collect digitally. For example, we have more than 1 million EKGs digital. We have MRIs, CTs, all the physician notes, nurses' notes, everything. And on top of the data, we have created a level of registries. For example, a cardiovascular registry, diabetic registry, which is not so trivial because who is diabetic? Somebody with a diagnosis, somebody with high glucose. So if you take only one parameter, the sensitivity and specificity won't be good enough. So we created very sophisticated algorithms in order to decide exclusion and inclusion criteria, automatic, to make those registries. And within the registries, we have sub-registries, like cardiovascular, who is post-MI, atrial fibrillation, etc., etc. So data is something that if you don't use it, it's not good enough. I always claim that we are the QA of the organization. We use the data, we find problems, and someday I want to write a book about the QA of data of a health organization. It's very important, very interesting. And of course, we can cross between registries. And it helps us doing research a lot better and quicker. But we all want to move from active disease to healthy people and prevent diseases. And we all want to shift because in the past we were doing symptom-based medicine, intuition medicine. Present, we always say we are evidence-based. We take articles, we look at articles, and we are doing evidence-based medicine. But in the future, and I'm sure more and more, and I'll show you some examples, we'll do a lot more algorithmic-based precision medicine for our patients. And that's why we founded the MK, Morris Kahn Maccabi Big Data Center, that I want to tell you a little bit about. It's new, we just moved there. It's an open space because we believe that we have to sit together, computer scientists, mathematicians, physicians, and ethic people, and law people, and see what we can do together. And we started a few weeks ago, and I invite you to come and visit and to work with us. And when we talk about big data, it's not only big, it's the variety of data. A lot of the data is in text, is in images, is in voice, video, and more and more. We haven't used it until now, almost nothing. The velocity of the data, we want to use the data just in time to show the results of the algorithms to the physician or to the nurse or to somebody that gives the care. And of course, if we want to give value to the system, nothing is important. Another V is veracity. You spoke about the quality of the data. It's also important, of course. So our team, as I said, is a domain expert, which is us, the physicians, the caregivers, the mathematicians, and the computer scientists. But as I told you before, the law people, the ethic committee, for example, in Maccabi, and the law department, we are coupled and we speak on a daily basis. And we want to make a platform that the base you see underneath is the data. Then we'll have anonymization layer, and we'll let everybody work on this data, even from distance. That's our goal. Every student from everywhere in the world will be able to work on our data. And we are working on this virtual research room that will be, of course, under regulation and under IRB, which is Helsinki, of course. But we want to give our patient the 4 famous P's: personalized medicine, predictive medicine, preventive medicine, and participatory. We talk a lot about patient-reported outcomes, which will be also data that comes into the system and is very important when you want to make a decision for a patient. So up until now, we have done mostly descriptive work. Most of our papers are descriptive. We describe what happens and why it happened many times. But very less is predictive, which is more important and more practical. And even less is prescriptive. It tells you what to do when you have a predictive something. And that's what we are aiming to do, more prescriptive work. And I want to share with you something that we implemented already in Maccabi. So this is a real patient of mine from Rosh Hashanah, where I practice family medicine. And he came to me with advanced colon cancer. And whenever we see advanced colon cancer, it's a failure of the system. It shouldn't be. So I asked him, do you have a family history? Did you have a change in stool? Did you have blood in stool? Nothing. All was negative. But then when I look at his blood test, and in Israel, we love blood tests. I don't know one place in the world that people perform so many blood tests. So when I look at his blood test, I see that it's normal, but you see that the hemoglobin level here is falling within the norm for 3.5 years, from 15.7 to 14. And we as physicians, we used to blame ourselves all the time to say, if I was seeing it here, it was 1.5 years before, I could do something. Maybe it was better. He died already. And so thinking about it, I got a new epidemiologist to my department because I knew that if he would have had an anemia, I would have sent him to colonoscopy, but it was still normal. So I told her, we are going to examine it. Descriptive. As I said before, it's descriptive. Let's take all the patients with colon cancer, were diagnosed with colon cancer, and did not have anemia, and see for how long they were losing hemoglobin within the norm. And you see, those are the controls, and those are the sick people, and that's the place where you diagnose colon cancer. And you see that on average, 3.5 years before, exactly like my patient, the hemoglobin level is starting to fall within the norm, which means we had more than 1,000 patients, and we published it in the Journal of Cancer Prevention, but we said to ourselves, it's not enough. Now we know that we have the problem. What are we going to do? And I decided to think within myself as a medical informatics, how do I prevent the next case? Shall I draw an arrow? So 50% of the time it will be here, and 50% of the time it will be here. So the physicians won't use it because you get alert fatigue, what we call. And you can see that this is a picture from Tel Aviv. They are doing screening, annual screening, and you can see that people love to do blood tests, and they hate to do FOBT. People hate to deal with stools. It's from your department, actually. You admit. And the question was whether we can use blood in order to say that this patient was going to be sick. Can we predict from a blood test that this patient was going to be sick? And timing is everything. You know, I got some visitors, some mathematicians, that they were doing algo trading, and they were asking me, do you have a problem that we can solve for you? I said, yes. They said, we made a lot of money in algo trading. We are interested in medicine. And they are very talented mathematicians, and we started working together, actually, informally, you know. They came to a coffee house near my house every Wednesday evening at 8 o'clock in the evening. We started sitting each week. And the challenge was to take age, gender, and CBC, and to see whether we can have a model that will predict colon cancer. And you know that here we started with the oops. Do we have ethical issues? And I'll give you some oopses that we saw along the way. So one of them was, can we give them the data in order to have the algorithm? How can we give them the data? Anonymized, de-identified? It's just a question at this moment. Helsinki, do they know how to deal with data, not as a study, the usual study, the data mining? How do they do approval for data mining? Boss, we just spoke about it. Questions. So, it goes back. Lama. רגע. 1 minute. Okay. So, we took the data, anonymized, we created a model, they created a model, about 2/3 of the population. We validated it on the other third, and we saw that it worked very nicely. And then we said, okay, we'll buy data from Thin, from England. We tried this model, and it worked perfectly okay. And what we found was very interesting, that even one CBC, age and gender, was prediction for most of the prediction, because in one CBC, you know that we have thrombocytes, MCV, MCH, the relationships between those parameters, age and gender, gave us most of the prediction. So we wrote a patent about it, and we felt that we have to use it in our system. And you know that if you have a family history of colon cancer, you don't send the patient for FOBT. You directly send him to colonoscopy, because he has between 2 to 6 folds time the risk of average person. But if we will use our system, it has 42 times risk of an average person. So we have to use it. That's what we felt. And we started to think about the use case that we have to use it for. So we found many very interesting use cases. Like every physician here had a patient who was diagnosed with colon cancer before the age of 50, which is the screening age in Israel, and it's very early, because in England, for example, they start 55. We start 50. But I have a patient who died, she was 48. We didn't screen for her. So we can look at those patients' data and diagnose them with higher specificity and call them. Maybe we have to change the way that we diagnose patients, screening for patients. We can go to interval cancer. When you do colonoscopy and it's normal, we say, come in 10 years. Maybe we can call after 5 years, we can use our algorithm and tell some of them come after 6 or 7 or 8. But we decided to start with the non-participant, who are at least 30% of the population. Because we work very hard for them to do it, we got to 70%. So those 30%, we said we'll start with them. And here we had another oops. Are we performing a test to somebody who didn't want to do a test? Are we allowed to do it? Also the physician, he didn't ask us to do this test. Are we doing this test without his consent? Questions. Maybe this patient is not eligible to do this test. Maybe he's sick in breast cancer now. Why should we tell him about another cancer? Maybe the patient doesn't want to know the results, because many of my patients tell me I don't do FOBT not because I'm lazy. I don't want to know what's inside. That's how they tell me. So those are questions. Or maybe we have to go to the other side. Maybe we have to do CBC to many more patients and we'll have more data about patients actively. So those are questions that we asked ourselves, and we decided in-house that we'll do it. We'll take the patients who didn't do any screening, we'll calculate it, and when it's positive, we get back to our physicians. This patient is positive. Just to show you the results, our results, you see that in FOBT, 70% are normal. In our positive, only 46% are normal. So we have very good results, and I have to show you, as an ethics committee, a patient of Maccabi that wrote me a letter and said, I came to the physician. I'm 86 and I was referred to colonoscopy, screening, and he told me, he was laughing at me, he said. He told me, how long do you want to live? You know, it's for 10 years, you know, and he didn't perform the colonoscopy. Maybe you can do the screening in your screening set because it's a lot less expensive. And actually we did it, and I told him, you know, I called him back and I told him you are not at risk. But a question of chronological and biological age and cost of screening is also something that we have to think about. So just to tell you that we have a lot more screening tests that we have algorithms for, like lung cancer, and I won't get into it. But data talks, and we have to listen to the data. And we have a lot more predictions on the way. And we ask ourselves ethical questions on a daily basis. For example, shall we help insurance companies to do algorithmics to find out who will benefit and not benefit? Is it ethical or not? And more questions. And also, is this the end of science? Will we have actually a black box that will tell the physician, in this patient, you have to do this way? You don't understand the physiology, but is it ethical to do it to the physicians? And I want to finish with visualization of data, which is also important, because you have a lot of data. How can you find your way in the data? And for the patients too. They look at us, we look at the computers, they are looking for our eyes, and we are in the data. So just to show you here.
Voilà. Professeur, on en est où?
זהו, אין זמן, נכון? Okay, thank you.
Thank you very much. I'd like to thank Professor Varda Shalev for this fascinating cutting-edge research, and invite Professor Ehud Grossman, the Dean of the Sackler Faculty of Medicine, to share his thoughts on this. Do you want to take the? Do you want to come here, or you're fine there?
People can hear me even without the microphone.
Yeah, the microphone is for
the recording.
So, yeah, thank you.
For the future. For the big data.
No, wait. This is just, you can put it in the middle.
Okay?
Like this, yeah.
Okay, fine. So first, thank the organizers for the very nice meeting and for inviting me. And just give you a short introduction of myself. I'm a physician, the head of the internal medicine department and hypertension unit in Tel Aviv Medical Center. And in the last 2.5 years, the dean of the Faculty of Medicine. And I'm involved in research mainly in hypertension. And this brought me to the big data information, because we have many questions in our field that don't have answer if you don't use the big data. And as Varda already mentioned, there are few possibilities to use the big data, and one is the descriptive. But the descriptive information that you get from the big data, I don't know if they have some ethical problems when you use this data, especially if they are anonymized. Give you a lot of answers that are very important for the patients and for the whole population. And I will try to give you at least one example that we did together on a question that is very important. As everyone knows, hypertension is a major modifiable risk factor for cardiovascular disease. And if you lower the blood pressure, you reduce the risk of stroke by about 40 to 50%. And it's very clear, everyone knows. But still, when we look at the population and we look at those who know about their blood pressure and get treatment, still about, we don't know how many, but many patients are not well controlled. And you ask yourself, first, whether is it true? Why so many patients cannot control their blood pressure if you have all the medications that can lower the blood pressure? And what is really the rate of resistant hypertension? As Varda told, already we have the registry of hypertension in the big data of Maccabi, and this gave us a chance to analyze the data and see, because in Maccabi you have also the diagnosis, you have the blood pressure levels measured in all the patients, you have the prescription of the medications that they were received, and also the purchase of the medications. So you can answer many questions. So we try to analyze the data together, and until we did our study, in the literature it was let's say, estimated that about 10 to 15% of the patients have what we call resistant hypertension. You cannot control their blood pressure, whatever you use. So we went to the data in Maccabi and we realized that it's not true. Why it is not true? Because we saw that many patients, first of all, did not receive the true medications by their physicians. B, many patients who received the true medications didn't purchase the drugs. So when we analyzed the data, we realized that the main problem of what we call resistant hypertension, is non-compliance of patients. Now this may change our attitude how to, let's say, improve the control of blood pressure by encouraging patients, explain, make the drugs simple to use. Don't prescribe 4 drugs, try to prescribe 1 drug that contain maybe all the drugs together. And the real, let's say, rate of resistant hypertension is between 1 to 2%. Now this is also important for the pharmacy. If you go to the pharmacy and say, okay, I want to promote or find a new drug, a new medication, a new procedure to lower the blood pressure, how many patients will use this, let's say, technique? When we did it, on the market was a new technology of lowering blood pressure, renal denervation. People try to do the renal denervation, which is an aggressive procedure to lower blood pressure, and the reason to do it because 10 to 15% of the population cannot control the blood pressure just with drugs. So let's develop a new technique. Now, if it's true that only 1%, then maybe the development of the technique is not worthwhile. So, I mean, this is again descriptive, but very important descriptive of database. The second, of course, is something that prescriptive. Try to see what we have and see the process over time, as Varda already told us about colon cancer, to identify people who are at high risk. Again, if you look at our approach of hypertension, many patients come to me because, you know, the blood pressure was well controlled and all of a sudden the blood pressure went up and they are very excited. I'll go to have a stroke tomorrow because my blood pressure now is, instead of 130/80, 170/100. And in most of the cases, my impression is that it's not true. It's just stress and it doesn't cause any harm. But many physicians send the patients to the emergency room to get the blood pressure immediately down. From data in Maccabi, in the big data, we can go back, take all the patients with stroke and see whether the blood pressure before the stroke in the last 2-3 weeks really was uncontrolled that caused the effect. So again, something that we can use, of course, to identify problems. And another issue that can come is, one of the main problems is atrial fibrillation. If we can go back and see and we know that if we give anticoagulation to patients with atrial fibrillation, we can lower remarkably the rate of stroke. Now, if we can identify a subpopulation that we can predict they will develop atrial fibrillation, high risk, we may use anticoagulation before they have the atrial fibrillation and then prevent the stroke. So there is unlimited options in analysis of the big data and come with conclusions that will, of course, improve our approach to treat patients. Of course, all this data should be in good quality. And what we have, I think, one of the problems that I have, I just tried to do a study from data in our hospital, and I add, you see, something come to my mind from what I see as she saw a patient with cancer, I see a patient with a problem, and I say, okay, something is wrong. I see this first, the second. When I see the third patient with the same problem, let's go to the data and see if this is really true. And I try to analyze data from our hospital, and I see that it is not true. And I say, how come? Because it must be. And then I went back to the data and see how much part of the data was not true. Because we didn't look at the creatinine, we didn't see if it was the same time. So when we analyze the big data, one of the problems that we must assure that the quality of the data is good enough to make the conclusion. And of course, we have to discuss, because this is the meeting of ethics, we have to discuss how we overcome the problem of the privacy of the patients and not expose the diseases, and when we give the data to someone else, how we can, let's say, keep the secret of the patient and not, but I think there is unlimited options with the big data in medicine, and I gave you just 1 point from my part of it.
Thank you very much. Thank you, Professor Grossman. Our next speaker is Dr. Shalev. He is the former General Director of the Ministry of Health, and he's heading now a big committee, multidisciplinary committee on questions of big medical data. Thank you for being here with us.
Hi, thanks, Edmond. We are the regulator, or as Varda would rather call us, the strangulator. So this is something that I'd like to address. As Varda said, we have a long history of medical records, electronic medical records. We have the ability to become a very significant player in the big data arena, we are small. We have a lot of technology. We have small number of insurers and providers, so we can do it. We have the platform. We have the. There is an increasing abundance of health data, myriad ways of collecting them. And there is a kind of a vacuum in regulation in the big data field, and absolute lack of enforcement. And basically, everybody does what he wants, what he thinks is very important. And I think the examples that we heard here were just good examples of great stuff that can be done with big data, and there is no question about that. There are impediments to sharing the data in the research community, and the health organization kind of monopolize the data. They don't share them. They use them, they don't share them. We have the ability to create a platform of maybe sharing these data. So, health organization, HMOs, and so consider the collected data as their own. Are they? There are no standard sharing platform, as well as lack of ground rules for data transfer transactions. There is no, it's a game without any laws, basically. It's out there. There are no commonly accepted guidelines for de-identification and use of de-identified data. The experience with collected data, either by private sector or government, creates significant public concern. Once the public knows that we use their data, this creates concern. We have not addressed this concern. So there are a variety of privacy concerns, Big Brother concerns, IP concerns, ownership concerns. The question who owns the data, because the patient owns his own individual record, but once it leaves him and the blood sample leaves the patient, whose is it? That's a question that has not been really addressed yet. The system is publicly funded, and we want to provide equal rights to everybody, not only to those in Maccabi or in Clalit, everybody. And the public has the rights to the fruits of the research based on the data. So in order to try to address these things, we created teamworks, committees, or whatever. Committees usually bring to the final decision that there is nothing that we can do. But so we'll call them teams, okay? So it includes experts, stakeholders, regulators, and public representatives. The one such committee is the Ethics Committee, and Professor Lavi is heading this committee. She's the head of the Israeli Bioethics Council. And actually, this group should lay down the principles according to which the system should implement and comply. The group deals with questions like the type of consent, opt-in, opt-out questions, exemptions from questions such as who owns the data is a question that has been decided not to address because we thought that this is leading us to a dead end. And the second committee is the Technology and Implementation Committee, which deals with technical and procedural issues, the specifics of de-identification, levels of de-identification, specifics of limitation, licensing, access, transfer of data, or access via data enclaves, and the cost of transfer. There is an Engagement Participation Committee. We are rooting for public transparency, and we would like to market the public the merits of data donation and participation while assuring questions concerning privacy and re-identification. So the way how we cannot go back to their specifics, addressing public concerns about privacy, abuse of data, making the public a participant, and you were speaking about the P's, in decision making and formulating the process, creating a communication platform with the public and user community, research and industry. We don't have this sharing platform. There is a committee dealing with incentives for disclosure and share and use. Health organizations gather information and invest in R&D. All players should have an incentive to participate while keeping motivation to continue innovative research and benefit for all. What is the part and the returns for the public and for the researchers? Funding is public, basically. And the data sources are basically public. I mean, it's the public, and it's a common source of money that comes out of... and it's not just money, it's the whole charade of goods that come out of research. So I just want to set the what we look as our mission statement. Israel is a profound interest in innovation, digital health, that's like motherhood and apple pie. It is our mission to promote usage of health data for the benefit of the public. Again, the same mother. We see health data sharing as a mandatory obligation, provided the rights and benefits are secured. The fact that source of data and funding are by and large public entitles the public to have a dominant part in the goods created through the innovations. What not? We don't want to turn regulation into strangulation. We don't want to choke research. We don't want to abandon our role as representing the residents of Israel and we don't want to stop being having a regulatory role and some kind, and this is something that we have to discuss, some kind of oversight on the usage of these data. At this point, we don't have any. We don't want to take advantage of our regulatory position and create a big brother. We don't want to enlarge and deepen the public mistrust in the health arena. And there is a significant amount of mistrust in the administration, at least. We don't want to create a bureaucratic maze and delay and hinder innovation. We don't. We don't want huge health organizations and conglomerates to monopolize the field and prevent small research and industry enterprises to participate. And this happens today. And we would like to minimize barriers. There should be, obviously, a hierarchy level according to the public interest concerning the type of consent and de-identification needed for each use. So there is a gradual ascent from levels of de-identification. That's not one issue, de-identified or not, obviously. Where are we going? Use of data according to public interest. The utilities should return to the public. To what extent? Question. Proper sharing incentive and IP rights for outcomes. Should be a public campaign to make the public part and parcel of this enterprise. The levels of consent will depend on the goal of use. And there will be exemptions. For instance, research within health organization should be exempt of research. So just to sum up, we want to create a regulatory infrastructure that enables innovation through research and data crunching while securing privacy and represent the public oversight. Create a platform for incentivizing research and industry while the public enjoys the utilities created by the innovators. Preference of data enclaves for sharing to data transfer. Avoiding unlimited and monopolized data usage interaction and enabling wide participation. Does not happen today. And formulate de-identification guidelines following the principle of least identification needed. The default is de-identification. Thanks.
Thank you very much. And our last presenter for this panel is Dr. Yamin, here from Tel Aviv University, from the Engineering Faculty. Dr. Yamin, please.
Okay, thank you very much. Thank you very much for arranging this multidisciplinary, extremely interesting meeting. So I'm in the Faculty of Engineering, the head of the laboratory for disease transmission modeling and analysis. And generally speaking, what we do, or our main focus, is on infectious disease modeling, but also we use, as a matter of fact, every aspect that can be related to contagious, to transmission in the broader sense, is an interesting topic for us for research. That includes social contagion, for example, smoking, and recently showed obesity. It can be viral marketing, computer virus, etc. I'm originally coming from the world of operations research, where generally speaking, or traditionally I should say, what we do is first develop a model, and then use the data in order to test the model, in order to validate the model, in order to evaluate missing parameters that are related to the model. And the models, generally speaking, have three main goals. One is to explain a phenomenon, to predict, as mentioned here, and to test intervention programs. It can be incorporation of cost effectiveness analysis when we're talking about health related issues. And in the context of this meeting, the big medical data poses, as we all said, tremendous opportunities, but expose us to several risks in terms of the privacy. And the greatest challenge of our work would be to design a framework where we minimize this loss. And as I said, the data, at least in our world, is a very important component, but it's not the main component. And what we try to do is to definitely use this big medical record, or to exploit it, especially the medical record, but together with other settings, together with other data, together with the enhanced understanding on several techniques of modelings, and an understanding on biological aspects, if we're talking about infectious disease, as well as behavioral components, decision-making topics, in order to achieve our goal. And in the sense of what we are doing, if you want to think in terms of information theory point of view, what we try to do in order to minimize the privacy loss is increase our information of all the other aspects in order to infer about those hidden or not allowed to use from ethical reasons of the medical data. And I'll just generally want to talk about two specific approaches, two specific models. One takes us to the Ebola crisis in West Africa, and another to our dwarf, to Israel. And several years ago, it was in the early beginning of the Ebola outbreak. Whatever we saw when we look at I shouldn't say the big data, but the data that we received, we saw a huge spike, exponential spike in the trend, and the CDC predictions were that about 1 million people are going to die from Ebola. And we got a great opportunity to get the data from the contact tracing team in Liberia. And as much as we think that it is understandable situation of using and entering into the privacy of individuals, because we're talking about a crisis, we're talking about a situation where there is not a lot of sources, so it might ethically sound okay to basically get all data that we have and exploit all of the data in order to generate as fast as we can a public health message. But that is not true, because especially in this particular situation, there was a lot of suspicion about the government, about their intentions, about this weird, not really clear outbreak. And we got data from the contact tracing team, but with a lot of missing components, and not because they did not have the components, it's just because they wanted to make sure that it will be sound okay from the public perspective. But by taking into consideration biological aspects and understanding the transmission patterns, and taking into consideration the data and the contact mixing pattern, all together, we could create a public health message, which was that the super spreaders are the non-survivors, and we can say in advance who are more likely to be in the non-survivors, and the super spreaders were this subpopulation that eventually will not survive, and they're in their between 4 days to 6 days of from symptoms occurrence. So basically, if you target those people for isolation, only those people, you can basically, we showed that there is a very high chance for disease elimination, and that was pretty challenging because eventually it was shown to be to work very basically perfectly explain the situation on the ground, but given the CDC and other model predictions, it was a bit hard to convince. But later on, I should say 2 months later, when we had the chance to meet with public health officials in Liberia, they said, you know, when we eventually got into a place where the contact tracing team asked the people how many days passed since the symptoms, when they said it was above 4 days, we knew that we are in a big problem. And when it was before 4 days, there was no chain, there was almost no infection. And the idea is that if you take all of the other components, maybe in some cases you don't need to enter to the privacy of the individual, or at least you can minimize it. Another work that we did was started from a theoretical standpoint. We used a contact network. In a contact do I have some time? Okay. In terms of contact network modeling, one can basically translate each individual in the network to a node and contact as an edge. And then you don't need to be Albert Einstein to say that if I think about this contact network, if you want to target for influenza, for example, for influenza vaccination, target the super spreaders in this network. The real challenge is that in real life, we don't know who is this, who are those super spreaders. But basically, our idea was that those who got infected in the year prior, why did they get infected? It is because they're more likely to be the super spreaders. So basically, the super spreaders are disproportionately represented in the pool of those who were infected with influenza in the year prior. And we had a chance to present this theoretical approach in one of the conferences in Israel to Professor Ran Baliser from Clalit. And he said, you know, that's really interesting, but I'm not sure it actually works. But if I give you the data and you can prove that can be an interesting public health or interesting intervention, we might do something with it. And indeed, we got the data from Clalit, 54% of the Israeli population, and the results were fascinating. After adjusting all the noises and being very conservative, we saw that regardless of the age group, regardless of the year tested, regardless of a lot of other tests, individuals that got infected in the year prior, individuals that got hospitalized in particular in the year prior, have substantially higher risk to become infected and to get complications of influenza. And when we're talking about ethics, we do know in the literature, for example, that Native Americans, for example, are 12 times more likely to have pneumonia. But it's definitely not ethical to say target this subpopulation or other. However, if we can bypass some specific policies that are subgroups oriented, but we can say, hey, you got a pneumonia in the year prior or in several years prior, you are way more likely, then it makes sense to basically to get the public cooperation to try to avoid ethic problems. And that is our challenge, and that's what we are trying to do, to take all data we can, all understanding in a lot of interdisciplinary components we can, in order to try to bypass, infer about this constraint. So thank you very much.
Thank you very much. Okay, so we now have about 15 minutes for open discussion, questions, comments. Yes.
I'm sorry I came late.
Could you please present yourself and
Yes.
speak up?
My name is Maya Fisher. I'm a PhD student and born in Kuwait. I work in Edmond in the laboratory. Part of the big data is a laboratory test, lab test. And I think that there is a question, there is a question about the validity of those tests, because a lot of the normal range were taken on. To begin with, all this data was taken on people who were actually ill and not healthy. And I think part of discussing what we take from this big data should also ask about. You were mentioning the quality of the data. I didn't know exactly what you mean. I think it's just, I would like to hear somebody.
Okay, thank you. Should we collect a few more questions before we respond, or yes?
My name is Eran Bareket. I'm a practicing attorney, but I also teach patents law at Hypertension University and here in Tel Aviv for more than a decade. And I'm also involved in Maccabi's project that Varda spoke about. I'm a strong believer in this famous saying of Ecclesiastes that what has been will be, what was done will be done again, and there's nothing new under the sun. And I believe that Ron is not here, but I think that we should learn from the history, and one of the most important advices would be do not try to reinvent the wheel. Look at what was done before, you'll get 95% of the answers. Secondly,
does that refer to the medical research or to the legal surrounding?
To the legal regulation, and to attempt to legally regulate to the ownership question, to the privacy questions. I think most of them have been answered before in very similar contexts. Secondly, we are dealing with innovation. Innovation being generation of new information that we were not aware of before. And one of the first questions that arises is who is going to manage this innovation? And what we heard from Dr. Lev, at least intimated, is that this government and the state want to manage it. Not only to regulate it, to create a national platform, all data will be there. And I think that, at least my personal view, is that past experience tells us that innovation is better run by the market, whether it's public bodies like HMOs or private companies, and not by the state. Secondly, I think there is an oversensitive, understandable, but oversensitive to the big data of the HMOs and the data itself. I think we should look more on the application of big data research in the application of the information to this field of private health information, rather than access to the big data itself. The big data research that is ongoing every day is tremendous. For example, I'll be very brief. For example, when we use our keyboard and we're using our keystrokes, someone can learn whether we are sick or not sick. Are we looking at that? I mean, the government and the privacy authorities should look at that as well. It's not a question of access to data per se, it's how the data is used later on. And lastly, the system needs money, the system needs resources. It's not trivial that the Maccabi has this facility or any other HMO that allows this access to research. Someone has to fund it, and as long as the government does not fund it by giving tens of millions of shekels to allow this, someone has to pay for it, and that is another challenge.
Okay, good questions? Yes, please.
I just wanted to add. Yeah, my name is Robert Moskovich. I joined the Department of Software and Information System Engineering in Ben-Gurion like half a year ago, after being at the Department of Biomedical Informatics in Columbia, in which I'm still an affiliated assistant professor. So I just wanted to add a few aspects about what was spoken earlier. Personally, I'm working on temporal data mining, biomedical data, and so about what you spoke, it's always interesting to understand what is the actionable knowledge that you could discover from your study. We can speak about it later. I just want to speak about sharing data, biomedical data, because someone spoke about it earlier, and there is a big project called the Odyssey, OHDSI, that is led by Columbia University. And specifically in Colombia, they have, I actually have from here, from Israel, access to the entire database of the New York Presbyterian database of 4.5 million patients. And I don't see why in Israel we cannot do this in each of the academic hospitals. I don't think the problem is regulation, because there are HIPAA instructions on how to do that, and it happens in the United States. I think there are different problems in Israel, and I think if as a researcher in a university, an Israeli university, if I have an access to the Soroka database, or here, it will enable me to make much better research instead of working hard to have a collaborator in the medical center in Ben-Gurion, in my case, and have, combined in a way, instead of just have access to the data and just do my stuff. Because we have amazing data here in Israel, and so that's my message. I hope I'm clear. So there is a way to do that. That's what I want to say. Technically, and it happens in the United States, there's no reason why it doesn't happen here.
Okay, so there are three questions on the table: the learning from the pathological to the normal, nothing new under the sun, and government intervention, and
sharing the data.
And then there's also a question of access and sharing data. Do people want to respond to these? But we don't want to leave questions open, totally open. So is this another question, or is this part of the discussion?
Part of the answer. I'm Alina Tias from the Ministry of Health. I'm doing a teaser for my session later on. About funding, I'll present the platform that we are currently building in the Ministry of Health for public research, and what does it mean to be a researcher of medical big data. I'll discuss it later on. And funding is not an issue in this case, it's a public platform. And as for Robert, which we are in contact, one of the panels that we intend to build is the Odyssey panel, meaning if you are a researcher that want to work with Odyssey data, you could use it on our panel. It will be in production in the first quarter of 2017.
Yeah, that's an amazing initiative.
Thank you. Varda, do you have anything to say about the question about learning from the pathological, about the normal? Is that a source of concern? Is that an issue?
First, Dr. Segal is sitting here.
Okay.
Some of the tests are done, screening tests. As I told you before, in Israel, healthy people are doing a lot of blood tests. So you can conclude from the healthy, and people to come to me, and Ehud knows it also as well as a physician, they say, it's a long time has passed since I've done my labs, and it was a month ago, 2 months ago. So we have a lot of normals, and that's also an opportunity in our data. We have 1 mega lab for Israel. All the blood tests of Maccabi is shipped to 1 mega lab. Everything is standardized. We know the background of the patient, so we can say whether he's coming as a screening, he's sick or not, is he treated with medicines, comorbidities. So we can do a lot more about new standards for lab tests. Just to tell you that we have done a lot of work of new standards for labs. So if you are interested, I can show you the work that we are doing with the mathematicians in our team. So we are doing it.
Ross, do you want to respond to the
Also
provocation that the government wants control?
Well, I think this is a misunderstanding. We don't want to run the research. We don't want to create a big brother. We don't want to do this. We want to have some kind of oversight about the targets of research, and that's one thing. And I think we cannot abandon our role as regulator. There should be some sort of regulation, and the amount of regulation should be discussed. What is regulated, how it's regulated, and that's part of the things that we're trying to do. Funding is a totally different story. Basically, it's an old, controversy. HMOs in Israel are funded centrally by the people, and all the people are funding Maccabi. That's right, they get some funds from other places, etc., like university, like everybody. Basically, the data are stemming from the people and funded by the people, by and large. Now, one HMO is very big, gets a lot of money, and has the ability to shuffle money from one place to another, but basically, it's the people's property.
Sure. I would just like to add, I presume that some of the studies that result in amazing results like yours saves money, right? Because if people are diagnosed earlier and treated at an early stage, and the same people, you save people's lives. Yeah, that's also good. It's fair process. But it saves a lot of money in health treatments, etc. So.
Yeah, but talking about funding, I just have to represent my institute for research. I get no penny, 1 penny from Maccabi. So I get grants from outsourcing corporations. I work very hard to get those grants, just a minute. But people from Maccabi are not paying for it. And every cent that we get for research, and from research, if we have late patents or whatever, is going back to the research institute for the benefits of our patients and the world. Okay? So
But the main problem is that as good as you guys are, and as diverse you have mathematicians, you have other, there is no, it's not, the fact that there's so many other people that can find maybe earlier the findings that you guys had, because as a matter of fact, if we look at the predictors that you're talking about, and I read a lot of your tremendous contributions, if we see what it belongs in a lot of senses to a place where the industry was 30 years ago. Don't get me wrong, everybody really appreciates the surveillance systems that Maccabi invested a lot of money to make, and of course what you are doing in the research center. But the fact that a lot of people, a lot of great minds do not have the access is a great problem.
Oh, but I just want to understand a little bit. What do you mean by 30? That this is where the industry was 30 years ago?
There's a lot of SPC. If I just take talking about predictions, and when you look at some data in some trends, these are things that have been demonstrated in industrial engineering widely, and there are lots.
So I just want to say, I hope that I was clear enough to show you that one of our aims is to make a platform that will be operable this year, I think in between March and June, and will access as a virtual room. I said it, but you still say what you say. So maybe I was misunderstood. We are going to take our data, put an anonymization layer, put the tools, and let people access the data that we have. And it's not only that we have the data, we work continuously to improve the data. Because if I'll show you the data that we got from Thin or from other places, it's very difficult to conclude from it. We work on the data to make it a lot better. And we want that everybody will be able to access the data.
That's all data that you guys have? Everything?
So everything is, we'll talk about it later, what is about text anonymization. No, there are problems, regulatory problems.
Yeah. Just to clarify the issue about funding. First
wait, just a second.
I want to raise an ethical question: is who is the owner of the data? And I give you an example. No, this is a good.
As boss said.
No, just want to give you an example. If someone moves from one HMO to another, can you transfer all the information that you have in your database?
By paper.
Just by paper.
Yes.
Why?
Why? Because the Ministry of Health did not have really. HLS7 mandatory that you have to transfer. There are rules how you code data and how you transfer data. I think that many years ago, the Ministry of Health had to do one thing, is and tell us, you have to use this and this coding system, and you have to to use the new version on this date exactly, and you have to transform it in this way. And I tell you, as a manager of the medical informatics department, when I had like 20 tables, because I had to take data from Tel Shomer and to understand it in Maccabi. They talk Yiddish. I have to take data from Belinson, they talk Spanish, transform it to Maccabi language. So I think that Misrad HaBriut, the Ministry of Health, had to tell us, don't create your own vocabulary in each place.
This should be one of the goals of the Ministry of Health.
Right? I agree.
The same language in all the HMO.
I agree.
Okay, so just a second now. I just want to. We're running out of time. I think, Eran, if you have 2 sentences, that would be good. And then Efrat, I want you to contribute, and I'll conclude.
2 sentences. I don't know that anyone is being prevented from access, but in order to allow access, you need funding. And someone should pay for it. That's the point. Someone should pay for it.
אבל זה לא ככה, אני אשמח לדבר.
פרופסור אפרת לוי-להט.
למה אתה אומר שזה לא ככה?
This is an opener for discussion, but I just want to address the issue of ownership and connect to what Eran said about not trying to invent anything new. All of these discussions about ownership were held to a large degree around 2001 when Israel enacted the genetics law. And basically, the Israeli decision, which I think was a smart one, was not to decide the issue of ownership, because it's not solvable, right? Actually, by Israeli law, by the patient's right law, my medical file belongs to me. It doesn't belong to anybody else. So now an HMO can say, but I've improved your data tremendously, so now it's no longer yours, but it's mine because it's better and improved. We all understand the difficulties of that. On the other hand, if the data is really only mine and nobody else can use it, that's also not a good idea for various reasons. And so what the genetics law did with samples was they said, the sample, we're not going to decide on ownership, we're going to decide on usage. And we can say, we're not going to, how do you say this, to make a law, a rule about who it belongs to, but we're going to make regulations and rules about who can use it and how they can use it. And I would suggest that we think about medical data in the same way, in the sense that it obviously does belong to the person, it also belongs to the organization that curates it and organizes it, But we should be looking at usage instead of spending endless amounts of energy on a question that I don't think can be really solved.
Thank you. So I'd like to conclude just by saying that although this session was devoted and we've learned a lot about the state of the art from a medical scientific point of view, I think that we see how the ethical questions are already on the table, not simply alongside, but I think it was very interesting to hear how the science is trying to work its way around some of the ethical questions. I think some of the ethical questions can't be worked around, and so we'll have to face them directly, and I look forward to the continuation of this discussion. After the break, we'll take a 15 or a little bit less minute break and convene again at 1:45.
Thank you.